Okay, so these words, you might see them, they're called mutually exclusive. Those events are events that don't overlap. Okay, so mutually exclusive is that they are never overlapping each other. Versus not is that they would have some kind of overlap. Okay, so what is the probability of drawing an ace or a face card from your deck of cards? So let's talk about this. Do aces and face cards ever overlap? No. Okay, there's no overlap. So how many aces would you have in the deck? 4 out of the 52. Or, what kind of math do I do when I see the word or? I would add. What's the odds of getting a face card? What are the face cards? All these, right? Jacks, queens, and kings. How many face cards are there? There's 12 of them. So that means my chances are 16 out of 52. So yes, they're exclusive. They did not overlap at all. Okay, what is the probability of drawing a heart or a face card? Okay, so how many hearts are there inside the deck? 13. Okay, there's 13 hearts. And when we just did this one, how many face cards are there? There's 12. Oops. But is there anything that is overlapping? Those 3 overlap because we counted them in the hearts and we counted them in the face cards. So we can't count them twice. So I'm going to subtract 3 that overlapped. Okay? So if you think about it, if you already circled all these hearts, then you would only count those face cards instead of counting 12 face cards. Okay, so minusing the overlap, so what do we end up getting there? 22 out of 52. So are they mutually exclusive? No, they aren't, because there was some overlap in there. Okay, so you can see these formulas up here. For that, we did the probability of one plus the probability of the other, and then we minus the probability of where they overlapped. So that's what we did. Okay, so that's how those formulas were working. Okay, if you roll a sum greater than 8 or a multiple of 5 when rolling 2 dice, you get a bonus 100 points in the game. What's the probability of getting this bonus? Okay, so the sum of a dice. Can you give me your chart again? Sum of a dice. Make a chart. Okay, so these are all the possible sums when I roll 2 dice. There's 36 options, right? Okay, what I'm going to do is I'm going to circle the sums that are greater than 8. So all the 9 sums, the 10s, 11s, and 12s. So there was 36 possible sums. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or, so I'm going to add, what are the sums that are multiples of 5? So I'm going to put boxes around those. So 5 and 10. So 1, 2, 3, 4, 5, 6, 7. 7 of those sums were multiples of 5. Were these mutually exclusive? Was there anything that overlapped? There was some overlap, so they're not mutually exclusive. I'm going to subtract 3 out of 36 because I counted these 3 tens. I counted in both of them, so I can't do that. So that should end up being 14 out of 36. Okay, so those should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so you can see that altogether there was 14 things. Okay, this one will be a Venn diagram question, so let's give ourselves a box, 2 circles. One is going to be titled, "They Skip Breakfast," and the other one is "Skipping Lunch." So we're going to talk about eating habits. Skip breakfast and they skip lunch. Okay, I'm going to start with this statement here. 22% of people or these are students, eating habits of students. 22% eat both breakfast and lunch. So that's going to actually go on the outside, right? They aren't inside a bubble because the bubbles are the people that skip. So then that's on the outside of the bubbles. So what is the total percent I should have inside the bubble now? What's left out of our 100%? I should have 78% inside the bubbles, okay? Now, let's add these two together. So 62 plus 24. That is 86%. So that's over the 78 that would fit in there. So what do I do when there's over? I need to put it in the middle. So how much did I overlap here? So 86 minus 78 is 8%. So that means 8% in the middle. 62% need to be inside the breakfast bubble. So I already have 8 in there, so I still need what? 54%? Because that whole breakfast bubble needs to add up to 62. And then the whole lunch bubble needs to add up to 24. So I need 16. Okay? All of that should always add up to 100 when you're done, right? Those 4 things. So here's the questions. Are they mutually exclusive? It would be a no, because there is an 8% overlap. 8% of the students were doing both things. Determine the probability that a random selected student skips breakfast but not lunch. So which number represents that, where you're skipping just breakfast? 54% probability. What's the probability that a student is skipping at least something? Anybody that's inside the bubbles is skipping something, so what was that percent inside the bubbles? 78%. If you're in the bubble somewhere, you're skipping some kind of meal, so. Okay, mother buys a new washer dryer set for $2,500. It has a 1-year warranty. She could buy a 3-year extended warranty for $450. The research, the repair statistics for the washer and dryer set are studied below. Should she buy the extra warranty? Okay, so let's give ourselves a Venn diagram with a washer and a dryer. Okay, I'm going to start with the both. There was a 3% chance you would have to fix both. So that's in the overlap. And the washer, there's a 22% chance of fixing the washer machine. So this needs to be 19 there, because 19 plus the 3 is the total of 22. And 13 for the dryer, so there's a 10% chance that just your dryer would break. What number is going to go on the outside for the people who won't have to fix anything? So what do we got there? This all makes 32. So 100 minus 32 is what? 68% chance that you're not going to fix anything. So what do you think? Should she buy the warranty? There would be a 19% chance that she would spend $400. There's this 10% chance of having to spend $300. And there's a 3% chance that she'll need to spend the $700 to fix them both. So what do you think? Is the $450 worth buying the extended warranty? What would you say, yes or no? I would probably not do it. Okay? Why would I not? The only thing on here that makes me spend more than $450 is this, and there's only a 3% chance. So because I'm not going to spend $450 on a 19% chance of spending $400. That's less money anyway. I'd rather just spend $400 to fix it than $450 to cover it. Okay, so that's the only thing I'm worried about. There's only 3% chance, so I'm chancing it. Okay, a car manufacturer keeps a database of all the cars available for sales in Western Canada. For Model A, it's reporting 43% have heated seats, 36 sunroof, 49 neither. Determine the probability that the car will have both. Okay, so give me 2 circles again. What do we have? Heated seats, so heated leather seats and a sunroof. Okay, I'm starting with this statement. 49% of the cars don't have any of those things. So that is going to be outside of the bubbles. 49 don't have anything. How much do I need inside the circles? What percent do I need? I need 51% in there. Okay, so what do I have? I have a 43% and a 36%. That means I have 79%, which is too much to put in there. That's too much. How much overlap would that be then? So 79 minus 51 is 28. So there's 28% overlap. So I need 43% in the leather seats. So 43 take away that 28 is that 15? And the sunroof, I need 36 inside the sunroof. So I already have 28. So now I just need 8 more percent. So the question is, what's the probability that they would have both? So my answer would be 28% would have both things, okay? So decide what needs to be in your circles, figure out the overlap. That's the key to that one.